everyone. I'm Liza Ikuran. I'm Nina Alansakla. And I am Christina Malinaw. And we are your Wrinkle Winners.
Good day everyone. Today, I'm gonna teach you how to graph the circular function of sine. We have this given table that the value of x is 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. This is a radiant measure that we can see in our unit circle. So now, let's obtain the value of sine function. Since our x is given, let's just substitute it. So, pi is 0. Pi over 2 is 1/2 or 0.5. To get the 0.5, you simply divided the 1 by 2 and you get 0.5. We get the decimal value to help us plot it easily in our Cartesian plane. You can also use your scientific calculator to get this by simply type the pi over 2 and the given decimal number, that is 0.5, and just make sure your scientific calculator is in radian mode. So pi over 6 is here, pi over 4 is here, and pi over 2 is here. 2 pi over 3 is here, 3 pi over 4 is here, 5 pi over 6 is here, and pi is here. Now, let's talk about the properties of sine function. Number 1 is periodic function with a period of 2. As you can see from 0 to 2 pi, it is the value of points that complete the 0 to 2 pi. It is periodic because after the interval of 2 pi, it will repeat its value. So from 2 pi to 4 pi, it has the same value. Next, since the curves are extended, both left and right, continuously the domain. So there is no restrictions in the value of x. Let's talk about now the range of our sine function. Range is the interval negative y, less than or equal to y, less than or equal to 1, or negative y, 1. So here in the graph, we can see that the graph doesn't exceed in the value of 1 and negative 1. Therefore, the maximum value of y is 1 and the minimum value is 1. Our graph never exceeds in the value of 1 and negative. So, the value of our y is within this range. Now, let's talk about the amplitude. Our amplitude here is equal to 1. Amplitude is known to be the farthest distance in the x-axis. So from x-axis is up to 1 unit of real. Then the graph of y equals sine x is symmetric about the origin because it is a function. So here our origin it's symmetric because we have pi unit to right and pi unit to left. And now you have there the properties of sine function. So our problem is y equals sine x. The period is 2 pi. So the graph is up to down.
Our problem is y equals 3 sine the quantity of 4x and 4. Now our amplitude here is 3 and 4 is our period and the other 4 is our vertical shift. Let's try to graph this equation. Since our vertical shift is 4, we will move our vertical line 4 steps from the origin. So 1, 2, 3, and 4. Our amplitude here is 3, so we need to go up 1, 2, and 3. From 4, which is 7, and down, which is 1. The period is p equals 2 pi over 4, which is pi over 2. So we're going to start here. Now, let's plot the period. So let's say it's pi over 2 here. All we need is 4 points. So, half of that is pi over 4. And half of that is pi over 8. And 3 times pi over 8 is 3 pi over 8. So they are the 4 important points that we need. So here the first one, it's gonna go up, back to the middle, then down, back to the center. So that's it. That's our graph.
So our problem is y is equal to negative sine of 1/2 x. So because it's negative sine, it's going to, instead of going up, it's going to down now. Because we have 1/2, it's going to be a horizontal stretch by a factor of 2. If we calculate the period, it's 2 pi over b, and b is 1/2. 2 pi is divided by 1/2 is the same as 2 pi times 2, so the period has doubled into 4 over 5. The amplitude is still 1, so that's going to be the same for the sake of practice.